Hey guys, welcome to BreVITy, and today we're going to solve a Facebook question called Move Zeros. So this question is literally what's given in the title. You have an array of numbers 0, 1, 0, 3, 12 for example. Your job is to push all the zeros to the right side. So all the non-zero numbers like 1, 3 and 12 comes first, and all the zeros are pushed to the right side. So this program feels so easy, right? It's just moving all the numbers. So why is it asked in Facebook, and why is this program important? Well, it all lies on the logic which you use to solve this problem. So which you're going to see now. So now I'm going to see how to solve this problem. So consider you have an input array 0, 1, 0, 3, 12. The first obvious method you can think of is brute forcing. So you can loop through the array, and for every zeros we can keep swapping it to the last position. So we are swapping 0, 1 at a time to its last position, and we are swapping the next occurrence of 0 to its last position, and goes on like that. So obviously this is a very bad solution, because if 0 is in the first position, we need up to n swaps for it to go to its correct position. So if you do this in interview, it's going to make your interview sad. So the next another good method you can think of is using another array. So if you have another empty array, you can loop through the input array, and the first value is 0, so you don't care, and for every non-zero element you can add it to the empty array. So we're adding 1 to the empty array, next it's 0, so we're moving on to 3, so we're adding 3 to the new array, and we're adding 12 to the new array. So our array has 1, 3 and 12 in its positions now. Now to add in the 0, you can probably loop through the same input array again to add in the zeros, or you can keep track of number of zeros and add it separately. So this obviously is a very good technique, because we having O of n time complexity, we are able to move all the zeros to its right side. But the problem is the space complexity. We need another extra array to do this problem. That's O of n space complexity. So now we're going to look at a very efficient technique, which is basically O of n time complexity, but O of 1 space complexity. So consider you have array 0, 1, 0, 3, 12. The logic we're going to use here is very simple. Instead of moving all the zeros to the right side, we can concentrate on moving all the non-zero elements to its correct position. So what does it mean? You have an input like this, and after moving all zeros, what position will be occupied by the value 1? It's going to be the 0th position, because it's the first non-zero number is going to be occupying the 0th position. The next non-zero number is going to be occupying the first position, and the next non-zero number is going to be occupying the second position. So it goes on like that. So it's much more easier to implement this. I'll show you how to implement. We can have a extra variable called index, and we can initialize it to 0. So now we can run a loop through the array from the first index to the last index to find all the non-zero elements, and we can move it to array of index. So the first value you're going to see while looping is 0. So if it's 0, we don't care, and we can move on to the next value, which is 1. So 1, we can store array of index to the non-zero element 1. So index here is 0, so array of 0 is modified now to 1. So after modifying, we're incrementing the index by 1. So what was 1, 0 is now 1. So the next value you're going to see is 0. So 0, if it's 0, we don't care, and we're moving on to the next element, which is 3. So the same logic again, we're going to make array of index to 3. In this case, the index is 1. So array of 1, which has the value 1, is going to be modified to 3. And we have to increment the index by 1, so it's now going to be having the value 1. So the next element is 12. So the same logic, array of index is going to be 12 now, and the index has the value 2. So array of 2, which is this position, is going to be 12, and we have to increment index by 1. So now we have got all the non-zeros elements to its respective position. Now to make the rest of the element to 0. So to do this, we can run a loop from index, because up to the index we know everything is in its correct position. So up to this everything, all the non-zero numbers in the correct position. So we can run a loop from index to the last element, and the index is 3 and the last element is 4. So array of 3 is modified, which is this is modified to 0, and array of 4 is modified to 0 again. So now we in O of n complexity, we have moved all the zeros to its right set position, and we just took one extra variable to implement this. So now we can implement the same thing using Python language. So to implement the logic in Python, first thing we need to do is to have the extra variable index, and we can default it to 0. And just like what we did, we can run a for loop from the first position to the last position. And if the value is not 0, so if nums of I, which points to the value, is not equal to 0, you can make nums of index as the value nums of I, and we have to increment index by 1. So this makes all the non-zero numbers comes to its respective positions, and now we need to make all the zeros comes to respective position. So you can run a loop from index to the length of the array, and we can make the nums of I as 0. So in this question, they don't want us to return anything. We can just modify the in place of the same array nums and just run this code. Yeah, it's kind of fast. So this is how you implement the same logic with with just one extra variable and O of n time complexity.